Welcome back to Mathville Mansion, mathematicians. In our last lesson, we practiced working with our multiplication and division facts to unlock the passageway to the greenhouse. Let's check it out. The professor has so many different types of plants growing in here. And check it out, our first puzzle. Interesting. So I know the professor wants us to practice multiplication and division, but what do you notice about the way this puzzle is set up? Are the problems already solved? Kind of. We know the product or quotient for each equation, but there are pieces missing here, here, and here. There must be a way to use the pieces we do have to help us figure out the missing part of each equation. By the end of today's lesson, you'll be able to apply the properties of multiplication and division to solve for missing factors, dividends, and divisors. Have your guided notes ready, and let's figure out these missing pieces. Let's prepare for this puzzle with a warm-up problem. What do you notice about this set of equations? The operation symbols are missing, right? How can you tell which one needs a multiplication symbol and which one needs a division symbol? When we multiply, we're working to find the total amount. So 4 times 12 equals 48. But when we divide, we start with the total amount. So 48 divided by 4 equals 12. That's because multiplication and division are inverse operations, or opposites. This relationship between the operations means they can be helpful when trying to solve for missing pieces. Give it a try with the first problem in the puzzle. 6 times something equals 42. What do we already know? One of the factors and the total amount. Is there another way we could arrange these numbers? Since we know the total amount, 42, we could use division. We can divide 42 by 6 to figure out the missing piece. 42 divided by 6 equals 7. So what's the answer for the first problem then? Exactly. The inverse or opposite. 6 times 7 equals 42. The next problem has something divided by 9 equals 4. Do we know the total amount? No, but what operation could we use to figure out the total amount? Multiplication, exactly. Pause here to figure out the missing dividend for this equation. Since we don't know our total amount, we can multiply 9 and 4 to figure out that total. 9 times 4 equals 36. That means our missing dividend is 36, and 36 divided by 9 equals 4. Up next, 99 divided by something equals 9. So should we multiply or divide to help us figure out the missing piece here? We know our total amount, 99, which means division is still our best option here. We know that when we divide, the order of the numbers matters. 99 needs to stay there as the dividend since it's the total amount. But can we rearrange these other pieces? Yeah, it's just like our work with fact families. When we know one part, we can use it to find the others. 99 divided by 9 equals 11, which means 99 divided by 11 equals 9. Great work! We found all the missing pieces. Was that an explosion? Oh, no. It looks like there was a problem in the lab and the door to the next room isn't opening. The hinges must be rusted in place. We should check out the next puzzle to find out how we can help. To make this mixture pour with care, times more or less will get you there. Solve each part to find what's true and watch the hinges work like new. Well, that's awful convenient. It seems we need to figure out the correct amount of each ingredient to fix the rusty hinges on the door. The mixture calls for 4 fluid ounces of blue liquid, but there's a note from the professor that says we'll need 6 times more than that. How much of the blue liquid do we need then? 6 times more than 4? That would be 24 fluid ounces, right? To be sure we avoid any more explosions, how could we check our work? Yeah, let's try the inverse operation, division. Does 24 divided by 4 equal 6? Yeah. Okay, now I feel better about that amount. Next, it says 40 fluid ounces of green liquid, but the professor says we should use 5 times less. If we multiplied 40 by 5, we'd get a much larger number. But it says 5 times less. That means we need a smaller amount. What could we do instead? Let's try dividing 40 by 5. That equals 9, right? Let me check. Does 9 times 5 equal 40? No. Wait, that's not right. 8 times 5 equals 40. That means 5 times less than 40, or 40 divided by 5, is 8. Whew, that was close. The last ingredient is a little tricky. It says 3 fluid ounces of the red liquid with a note from the professor that says 36 fluid ounces. We need to figure out how many times greater 36 fluid ounces is than 3. Think about what we already know. How can we figure out the missing amount? Pause to record your thinking in your guided notes. We have our total amount, 36 fluid ounces, so which operation could we use to figure this out? Division, exactly. 36 divided by 3 equals 12, so 36 fluid ounces is 12 times more than 3 fluid ounces. And it's just a double check. 12 times 3 does equal 36. I think this mixture is ready to go. Wow, it took the rust right off those hinges and unlocked the observatory. Cool. Our next puzzle is over by the telescope. Solving these problems should give us the coordinates we need to point the telescope in the correct direction. Pause here to solve them in your guided notes, and we'll check them out together when you're done. For the problem 8 times something equals 72, we know our total amount, which means we can use division to solve. 72 divided by 8 equals 9, so 8 times 9 equals 72. Next, we have something divided by 3 equals 9. We don't know the total amount, so how can we figure this out? With multiplication. 3 times 9 equals 27, so 27 divided by 3 equals 9. And finally, if the comet moves at 32 miles per second, but the meteor travels 4 times slower, how do we find its speed? Right, division. If we divide 32 by 4, we get 8 miles per second. We have our coordinates, 9, 27, 8. Wait, that's just pointing across the room. Whoa! So, what have we learned today besides the fact that our math skills just keep growing and unlocking new mysteries? Well, now you know that multiplication and division can help us solve for missing pieces by using their inverse or opposite relationship. Multiplication can be used to find missing dividends, while division can be used to find missing factors and divisors. You've also explored how multiplication and division can be used to check your work. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with multiplication and division. Professor Puzzleworth has one last challenge for us, and we'll need every skill we've learned for this final climb. Who knows what awaits us at the top, or who we might finally meet. Remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.